So here's an example using our equation above. So for example, let's look back at the situation of tossing two coins and the event of getting a heads. Okay, so we had a sample space here, right? And here's our event getting a heads. Right? So the question is, well, what's the probability of A? So remember our event A, so probability of getting heads, or P of A for short, right? Because that's our event, is, well, how many ways did this happen? 1, 2, 3 different ways. Divided by the sample space, 1, 2, 3, 4 ways. And there we go. There's our answer there, right? 3 or 4, or 0.75 or 75% in all three formats. Okay. Again, mostly you're going to be giving me in these two here. Fraction is less likely to do it. So why don't we try one so you can see how this worked out. So question 4 says, for a recent year, there were 6,511 cars that crashed among the 135,670 cars registered in the United States. Find the probability that a randomly selected car will be in a car crash. All right. Now this is a good question: is how do we define our events, right? So in other words, like what is this? How do we define that event here without actually telling us? So event A is always the question being asked of you. So that's always your event. So what's being asked of us to do? Find the probability that a randomly selected car was in a car crash. So that is our event. That someone who's in a car crash. So the event is always what's being asked of you to find. So which means we want probability of A, right? Because we want the probability P of A. So for that, we go back to our equation, right? So in this case, we don't have to find a sample space or the event A, right? It's already given to us. How many people, how many cars were in a car crash? 6,511. And our sample space is how many people, how many registered cars? Which was 135,670 cars. Okay. So therefore, our probability of A would be, well, the event A, so that's how many times it happened, divided by our sample space. And there we go. And at this point, we just divide and we get our answer completely. So 65111 divided by 135, 670. So about 0.04. Oh, since it says 8, so it'll be 8 for 3 decimal places. And there we go. Okay, so let's try some more. Go to the back page, try some more out. So question 5 says, assuming that one of the 98 subjects is randomly selected from the table. So we have a table, lie detector test kind of thing. Okay. Question A says, find the probability that a person selected got a positive test. So again, we want to define our event. So what is being asked? We want somebody who's got a positive test. Okay, that's what we were looking for, right? Our sample space is everybody involved. So how many total people? So 98 total people when it comes to it, right? All right, how many people got a positive test? So remember, right, just positive. We don't care if they're light or not. We just want a positive test. So if you want, you can break this down and see how much you have total. So positive test would be the sum of these two together, right? So we list it out, right? 98 would be here, 51 would be there, 47 would be there, and then the 51 would be there. 57 would be there, and then 41 there, right? So how many total people got a positive test? 57. So the probability of someone who got a positive test is going to be 57 divided by 98. Okay. And then now at this point, right, we just divide it. So 57 divided by 98, round of 3 decimal places, gives us 0.582. And there we go. Okay. Now let's get B. So B says, find the probability of someone who selected lied. All right, so C will say it's someone who lied because that's what we're looking for. Sample space is still the same, which is nice. So now how many people lied? So this one says not lied. This one says lied. So total people lied, 51. So the probability of this happening is 51 over 98. And then we just divide. And there's your answer. Okay, let's keep going. We have a couple more to finish off this section. So 6 goes back to our child one. Find the probability when a couple is having 3 children, they will have exactly 2 girls. Assume that boys and girls are equally likely and the gender of any child is not influenced. All right, so let's say E is my next one. E then is having 2 girls, right? Notice that's what being asked of us to find, 2 girls. Now, believe it or not, we actually already did this earlier, right? So we already wrote down our sample space because, we didn't know what it was, and that's over here, right? That was question A. So we wrote down all the sample spaces possible. So this is a total of 8 outcomes. Now, how many outcomes are there having 2 girls? So I'm just going to list them out just to make it sure. So having 2 girls, we had girl, boy, girl, 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 boy, and then boy, girl, girl, right? Those are the ways we can have 2 girls. All right, and this is 3 outcomes. So the probability of out of 3 children is going to be, well, how many ways it happened? 3 ways out of a total of 8 outcomes, or 3 over 8. Okay, so 3 divided by 8, 0.375. And there we go. So sometimes we do have to actually create our sample space, and sometimes they give it to us. But you have to identify when you have to create it. Like this one, we had to create it, but we had it earlier. The other ones was given to us already in the tables, right? So like example 7 is already given to us. So it says a survey was done to see if Taco Bell / Del Taco use better meat, would they lose money or gain business. Among the responses, 2,051 said they would gain business, 257 said they would lose business, and 1,327 said they would stay the same. Find the probability of randomly selecting a person who said they would gain business. So what am I, F? So F is someone who gained business. Again, this told us how many said they would gain business, right? So 2,051 said they would gain business. Okay. Now the sample space, right, is, well, how many people were in my survey? So that's the sum of all these put together, right? So if you add them all up, you should get roughly 36, 35. So the probability of this happening, someone said would gain business, is 2,051 over 3635. And there we go. Hopefully not too bad. Okay. All right, so the last part of this chapter is something called, or this section, is complements. Okay. So a complement is the opposite of an event. So given an event A, the complement denoted as A with a bar on top consists of all outcomes in which event A does not occur in. Okay. So let me give you an example of what it means by, this kind of stuff. So let's suppose the sample space S is the numbers 1 through 9. Okay. And let's say event B are the numbers 2, 5, and 7. Okay. So the complement of B, or B bar, right on top, would be all the numbers that are not in here, meaning the rest. So I'm going to list out all the sample space except the numbers in B, which would be 1, 3, 4, 6, 8, and 9. So notice they do not overlap, right? They have nothing in common. So that's what it means by a complement, is the complete opposite of one each other has itself. Okay? So here's a key, very important concept we'll talk about later in the course is, well, if we find the probability of each one, so the probability of B, right, would be 1, 2, 3 out of 9, and the probability of the complement will be 1, 2, 3, 4, 5, 6 numbers out of 9, right, respectively. What happens when you add both probabilities together? So like this. We get 9 out of 9, or just 1. We get the entire set. Notice it's everything put together. And this is a very important equation. We're going to do a lot more as of, later on in the course, but it's a good introduction as to what's happening now. Where if you take the complement plus the original events and you add them, you will always get 1 because they do not have any overlap, right? It's just a complete unison. Okay, so that's what, it's a brief introduction to complements. Is all it is it's the opposite of what over here. So for example, in the last example here, F bar right? The complement of F would be someone who said, someone said, other than gain business, right? It's just someone that didn't say gain business. It's just the opposite. So I don't care if they said they lose money or they say the same as long as it did. They said did not gain business, right? So it's the complete opposites of each other when it comes to that. Okay? Same thing applies here. Instead of having two girls, you only have one girl, right? It's the complete opposite of it when it comes to it. Okay. All right. So last thing about this section is unlikely and unusual events. Okay. So unlikely events. So unlikely event is a probability that's super, super small. So we're going to break it down. Anything that's less than 0.05 as your answer is considered an unlikely event. So some questions ask, is this an unlikely event? And just look at your answers. If it's less than that number, then it's an unlikely event. So unlikely to happen. Does that make sense? Unusual event's a little tricky though. So unusual event is if the event is as low number outcomes or high number outcomes that is far from what you expect to happen. So let me give you a quick little example here. Let's suppose I toss a coin 1,000 times. Okay. So since it's 50-50, right, you probably expect 50 heads and 50 tails, right? Which you kind of expect. But let's suppose I toss it 1,000 times and 900 heads came out. That would be considered an unusual event because that is number is very high than what you expect to happen. So this will be called unusual because again, it's not what you expect to happen. You see it 50-50, so this should be around 500 when it came to it. So that's considered unusually high when it comes to it. The alternative is, well, if I do this 1,000 times and 100 tails come out, that's considered unusually low outcomes than what you expect. For the same reason, right? You expect this to be 50-50 or 500 500. So this is extremely high and this is extremely low. So both of these will be unusual events. And it all goes back to what you expect to see outcome.